Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. The session will run approximately 1 hour with questions throughout, and I'll now turn it over to our speakers for introductions.
Awesome. Hello, everybody. I am Sam Wronski. I'm a regional cloud advocate here at Microsoft. My job is to help empower all of you to build awesome things with Microsoft technology. I'm joined again by Bruno, who is my peer. Do you want to introduce yourself, Bruno?
Yeah, sure. Hello, everyone. My name is Bruno Capuano. I am here in the north, in Toronto. We are enjoying the summer because winter is coming, literally coming. And hey, I'm also a cloud advocate. I really love to help people to learn new stuff. And I really appreciate this idea that Sam's created about learning all together, sharing technology. So I will also ask people online that, what do you think about this format? Do you like this format or not? Let us know in the comments. You can use the comment to contact with us. And hey, today is also a special one. Let's do Azure Machine Learning. Let's see if we can build something cool with the platform.
Right. So let's, I guess, quickly introduce what this is. This is our Let's Learn stream series. So you know Azure Machine Learning and you know machine learning in general. I don't. I've never done anything with Azure Machine Learning at all. And so hopefully by the end of this, we'll have something, and I'll kind of understand a little bit more about how to do that. And hopefully we'll do that. And then tomorrow we'll actually be switching roles, and I'll be helping you learn a little bit about infrastructure as code. So if you don't know anything about machine learning, hopefully this kind of helps you along. Feel free to ask any questions you have as well, and hopefully one of us can figure out a way to answer them. So. Awesome. What are we doing?
Yeah. So, hey, this is a super cool start. And let's add some context here. There are several ways that you can do machine learning. But you probably ask, okay, but what is doing machine learning? What I mean? So, hey, if you are a developer, if you are a programmer, or if you're working with computer, this is basically building a kind of a function that you are going to provide an input, and they're going to, part of this is create what we call a model that is going to receive an input, which can be a string, an image, a set of data, or whatever, and it's going to give you an output. And an output can be something like, hey, if we are doing the typical, this is a dog or a cat, to do image classification, so the output will be, I analyze your image and I found that this is a dog, this is a cat. Or today we are going to do an example around detecting if a text is toxic or not. We are going to use a data set, a public data set, to do this. So in order to create this, there are a couple of pieces that we need. Of course, we need to have some storage. We need to storage our images. We need some compute because we need to use GPUs or CPUs to train those models. And we also need to define a place where we are going to do this. We are now going to define the steps that we are going to do. So how we are going to organize the images, how we are going to sort the data, and all of these things. So when we are working alone, without tools, we start to figure out how to do all of these pieces. Azure Machine Learning is a super cool platform that basically help us to have, I will say, more than 90% of the artifacts and tools and frameworks that we need when we are doing machine learning all in a single place. And it's all on top of Azure. So we are going to talk about the storage here. We are going to talk about data and data sets. But internally, it's going to use workspace and blobs and the stuff that we have in Azure. Same when we talk about SQL, it's going to use Azure SQL, and all of this stuff. So if you take a look here, if you see, this is if you want to navigate this, if you want to start this, we are going to share a link with a super cool Learn module. But this is ml.azure.com. And if you go to the home in the left toolbar and you click on the home, you can see here that the three main elements tools that we can use to create a machine learning model are notebooks, which is basically coding. We are going to code here in Python, similar to what we tried to do last week. Then we have designer. This is the one that we are going to use today, where we are going to, using a canvas, we are going to drag actions, small blocks, and we are going to connect the blocks and make the configuration for the blocks so we can also train a model. And then we have a third one, which is called automated machine learning, which is kind of a super cool because it helps us to avoid the learning, going deep sometimes into machine learning. You go to AutoML and you say, hey, AutoML, I have this text. I want to make, I want to classify these comments or tweets if they are toxic or not. This is my data set. Do your magic. And AutoML is basically going to start to train using different algorithms, different configurations, and it's going to give us, okay, I solved your problem, and this is the best algorithm and configuration that you can use to get there. It's super cool, super great. It's only working in specific scenarios, and we can talk about this other day. Super cool. But this is the three ones that we can use to create stuff. If you take a look at the, if you open the toolbar in the left, in the top hamburger, there it is. It's not a hamburger there. You can see that we have more stuff. We can create using notebooks, AutoML, and designers, but we can also have access and manage our data. Jobs is every time that we want to train a model or publish a model as a web service, we are going to train a job. We have components, pipelines, environment, because we can use this and create the typical dev, pre and pro environments, and then endpoints. If we are publishing our models to be used on the web, this is going to use Azure Kubernetes Service, which I am learning some to some, to publish the models there, and much more. So in example, in order to do this today, I asked Sam to create, can you click on compute in there? Yes, to create one compute element that we are going to use, which is basically a virtual machine. This is a virtual machine. When you create one, it's going to ask you, okay, we have several options, of course, from the cheapest to the most expensive ones. Cheapest is probably very low, very small CPU, very 4 gigabytes of RAM, very small storage. The big ones are, we are talking about Tesla, GPUs, super expensive. You pay the price, but they are super powerful machine. But this is what we are going to use in the compute side. So in the same place, this is the part that we can manage our storage, we can manage our endpoints, we can manage authorization, and even connection with other Azure services. So again, Azure Machine Learning is kind of a layer to do machine learning on top of tons of Azure services, but it makes our life so much easier. And that's my intro.
Yeah. So we have done some setup before starting this. We kind of set up this compute thing. So to do that, I created something, an Azure Machine Learning instance in the Azure portal, yes, and then launched the studio. That's how I get to here. And then there's different compute things. You might know more than I do. But the big change, or I guess choice that I seem to have, was either creating a compute instance or a compute cluster, which seems to do a series of machines. I chose a compute cluster for this. So that's what we have. To do that, you just click new, and then you get a whole bunch of different options for things to create. And for this, we're using small things, so I just picked the cheap one.
Yes.
And we're good to go, I think.
Yes, but if you select there before you close, if you go for GPU in example, instead of go for GPU, and just to show to the audience, and you select all options, you are going to see there that, oh my God, there are big ones here. You have somewhere here, you have NC24 or NC the Tesla ones. There are very, very big machines. And again, this depends on the scenario. This is pay as you use. So you are not going to pay this all the time. You're going to pay your machine while you are using. But if your machine is running all the time, you're going to pay your $20 per hour there. So there are plenty of options here. I really, really like to start, like we said, with the cheap mode. And then when we move to bigger data sets or more complex scenarios, the options here are amazing. But hey, let's go and start to create something. So if you go to in the toolbar in the left, if you click on designer.
So expand this and then click designer.
Yes. So what we have here is, this is, as I said, this is kind of a drag and drop scenario. We connect the dots. It's very similar to Scratch. If you ever done programming for kids, Scratch is super popular. But I like it because it's super powerful in terms of, hey, I use this a lot most of the time when I am going to do before doing Python, because I go here and at least I know the minimal steps that I need to do working with data or images to solve a problem. So there are a couple of templates. Let's go for the first one. If you click on image classification using DesNet, this is going to pick up one of the templates. And what we are going to see here is a blank canvas. And oh, yes, first time. So click on got it and probably have some, yeah, sorry about that,
Done.
Tutorial.
Right, I have you, so we're going to ignore those.
Yes. But hey, this is the canvas. This is what you have. If you move around try to get a start from bottom to top. So probably at the beginning or in the top of the, yes. So we start with the data set. We have data sets. We have sample data sets. We can create our own data sets. In this case, we are using a public one. Okay, I think it came from the OData information. So if you right click there, you're going to have some option to view the data. You have some even documentation there. Right now we don't have anything, so you can hide this. There's a button in the panel to hide this. But this is the ABC of solving a problem with images. So in example, what this problem with this experiment is going to do is going to pick up this data set, is going to sort the images into directories. So it's going to put all of this is animal classification, so it's going to put dogs in a folder, cats in a folder, and I don't know, little lizards in the other folder. Then it's going to split this data set in two parts. Usually we do this in the machine learning a lot. We split the original set of data 70, 30, 80, 20, and we are going to use 17 example to train the model. And with the other 30, once the model is training, we are going to evaluate. Okay, I train a model. Let's use this data to see if my model is good or not. So you have here the split in my directory, and it's going to do a couple more stuff. This is kind of a complex to start, but what you see here is what we can do. Drag components, drag images, and connect. So let's start one from scratch. I shared with you a couple of text files, so let's create one from scratch. So go back to Designer.
Okay, and click the plus.
Yes. Let's go for the clean one, and there it is. And in machine learning, we have the ABCs: data, train a model, and run. And let's start with data. We are not all you see here. You see that we have a list of data.
Oh, you mean these on the left?
Yes,
side?
This is all sample data set that we can use. There are plenty of stuff that is available to use, but for us, we are going to use our own data set. So if you click on the plus button there in the data,
to grab this and then
yes. So we can import and create our own data set from a local file. This is what we are going to use now. If you already have the data store in Azure, we can do this, or even from a web service or whatever. So we have it here. I think you need to upload. I don't know if you can drag and drop. So give a name, Wikipedia detox, or no, it's in the next step, I think. So
okay.
We need
so we want this to be Wikipedia
detox 250, just in case, because we are going to use. Perfect. So we are going to create a data type, a data set of a file. Don't need a description. Then from here, tabular file.
Next.
Then if you can browse the file, I don't know where you download the file. I don't know. I just realized we don't have drag and drop, so you need to unzip.
Okay, it doesn't like that. Let's grab this from a file or a folder from a file, probably.
For a file, yes.
All right. So let's go. Sorry, I'm gonna.
Yes, I know. Personal machine, you can have folders with whatever.
Yay. Okay, so we grab that. There we go. So this is our 65 kilobyte test data. So this is 25 lines or 250 lines rather of Wikipedia text.
Yes, and we are going to see the preview now in the next step. But just in case, go back.
Go back.
Yes, and change, instead of file, change of tabular, because it's tabular data.
Okay.
And then go next and upload the file again. Oh, there it is. So that's the file. This is what we have. And press next. And this is what it's going to do. It's going to upload the file. This is a very small file, so it's not going to have anything else. And we are going to have the preview. And what the sample file that we are going to use is basically Wikipedia. Wikipedia released a lot of data sets with comments and analytics around people interacting with Wikipedia. And they release very, very cool ones to train these sentiment analysis models, where you can see comments and you have there if the comment are toxic or not. So be aware that some of the comments are not nice.
Not great. Yep.
But hey, we have this we can use it to train a model, and I like it a lot. And this is a very simple one. This is only have an ID, a sentiment, and a sentiment text. This is the only thing that we find in the file. We have a bigger one that also have the year, have the user name, have the related article. So if we have time, we are going to see how we can also use a bigger one. But that's basically it. If you press next here, as you can see, automatically detected the file, automatically have everything. If we are importing a big data set and have, I don't know, several columns, we don't want all of the columns, we can here define, okay, I need this and I don't need that one. This is fine for us. It's also here smart enough to understand that the sentiment is going to be 1 or 0, toxic or not toxic, and the text is basically the comment per se, so it automatically do an inference of the data type. Yes, it's going to be an integer and it's going to be string, so that's fine. We don't need to change anything here. And yes, sorry.
Can this automatically detect? So, for example, if I switch this to Boolean, would this change the 1s to true and the 0s to false, or would that break the parsing?
No, it's probably going to break the parsing because we have right now 1s and 0s, but hey, because it's Boolean, it may work. But let's keep it in integer, and we make a test there for anything. By the way, we are doing this using if you press next and press finish, next one.
And
yes, click profile after creation. So what it's going to do is going to be available in our data, in the data set list that we have there, and we can start to use it. But we can also, if we want, add this using code. So if you want to add your own, instead of using the wizard, using code, using C# or Python, Azure Machine Learning have an amazing SDK that allows you to do this. So if you want to, an example, what you mentioned, if I want to double check a specific data type and make some conversions or whatever, we can programmatically do this. But for the example, which is kind of small, this is good enough. And as you see, there it is. We have our super cool data. You can drag and drop to the canvas. That's our first step.
Okay. What do the symbols on the bottom left mean? Is that
the version? This is that's a super cool question. Sorry about that. I forget that, and that's something new. I haven't seen this in a while. So if you go, we are going to get back here anytime soon. Sadly, and this is super sad, right now our designer experiment name is what you see in the top, pipeline created on 07th. So it's the ugliest name ever. If you go to settings, click settings there. We can change the name there in the bottom. Add your name. Sentiment analysis, Wikipedia, Labs 1.
Okay.
And scroll up a little. This is important. Here, because we are going to use this, we need to define what we want to use to train this. So go for cluster, yes, and select yours. There it is. And then we can save this and going back to your question. So you can collapse this.
Okay, so it saves automatically, or do I have to click the save button up here?
I think if you expand the 3 buttons there, I don't know that this has auto-save, but yes, it's not by default. So now it's saving automatically.
Okay.
So going back to the question, what is the big one? If we go in the asset section in the toolbar in the left, in data.
Yep.
Little more in the left, in the assets data, where you see designer, there it is, data.
Yeah.
Cancel, just in case. Yeah. The autosave is not saving.
Well, We'll do that. There we go. All right. So we're saved. And then go to data.
Yes. So we see your data set, version 1. If this is connected to that data store, the workspace blob store is literally a blob in Azure. So if we go to the blob and add a new file with different data or whatever, and we refresh this data here, is going to create a new version. So you see here that you can also do this. I'm sorry, I never create versions from the wizard. I always do this programmatically. But the idea here is that you can create a new version. Can you open the new version combo there?
New version. Okay.
Yes. So it's the same wizard.
Another file.
So you can do this, and the nice thing is that you can create a new version when you're running an experiment, when you're running your model. You can choose, okay, this is not working. Let's roll back this data set to the previous version. The standard developer process to do this and this, and hey, that's kind of nice that we have everything here to do this. And by the way, it's super important. If you click here on consume, in the top, you see details there, consume. Hey, if you are planning to use this from your own Python notebooks in Azure or outside Azure or whatever, you can install the Azure ML SDK, and here is the 10 lines of code that you need to answer this resource that you have right now, which is kind of super cool because even you can use this to access your data on Azure Machine Learning. If you scroll to the right, you see here that once you access your workspace and your subscription, you can say, okay, this is my data sets, get by name this, or get by name and version and include the version. So several options that several ways that we can use this. Let's go back to the designer and let's start to play around with data.
All right.
So in the list below, there it is.
There we go.
Yes.
So there's that. And now what do I do? Go to components?
Yes, let's go for components and let's search in the search window one component which is called select columns. Select columns from the select column. I think there it is. So you can connect both. So the output of the data, and when you click that one and you open the settings, you probably need to hide the one of the panels in the right. So there it is. We are going to select the columns that we want to use to work here. In this example, if you click on edit column, this is the way that it works. We have a properties windows on the right and we start to select. Hey, we can start to select the column names, go for sentiment, go for sentiment text, click again, sentiment text. We only have 2 columns and we are going to use 2 columns. That's fine. We don't need this step. Let's leave it here just in case for the next one. But there are other components that we can use. If you go back to the component filter and you start to do, I can't remember, I think it's duplicate, clean. There's another, which is duplicate row. There is another one that we can connect. And we can add it. We are not going to use this one here. The data set is small enough to do this. But hey, we go to duplicate and we say, okay, check these columns and this column. And then you have clean missing data. If we have a big data set with a lot of undefined values, a lot of empty values, we can use these components to clean the data, to work with the data. This is something that in Python or even in LinQ, we do a lot when we're working with data. Here we have these visual options to do this. And again, they are super useful. You don't need to write code. It's everything here. So let's remove the duplicate rows. Yes, that one.
Cool. And
we have this. We have our initial set of data. We have the columns that we're going to use. Let's do the split. Remember when we see the images? So there should be a component which is split data. There it is. Let's connect the output of there it is, one with this. And then in the properties of this one, this is basically how we split the data for training and for evaluation. I always do 75, 20% or something like this. If you go there, 0.75, that is going to be, as you can see in the bottom of the split data, there are 2 nodes for connections. So data set 1 is going to have 75%. And the second data set is going to have 25. And also important here, the way that this works is basically when we do the splits, we can define not only the how many is going to be for training and for data, also it's going to be if it's randomized, so it's not going to be the first 70% to do this and the second is going to do that. It's going to use kind of an algorithm to split in this. And you can also have a seed here to do the random out of the box. The parameters out of the box are good enough to do this. Does this make sense so far?
I think so. Yeah, I think this makes a lot of sense. So what we're doing, we have the select columns. That's not required, is it?
No, for this scenario, we have 2 columns and we are using 2 columns. We can avoid that one, but I want to leave it there because if we switch to the bigger file, we are going to use the select column. So I don't want to change the full diagram, only the big one. But yes, we don't need the select column for this one.
Okay, and then we have splitting data. So when we're selecting the percentage to split, that percentage is going to the left-hand side, right?
Yes.
So, okay. So that's this one.
Yes.
And then the remainder goes to the other side. And that's then is there...
And it's not a standard split. So if we have 100 files and we say 70-30, it's not going to do 1 to 70 here and 71 to 100 in the other place. It's randomized. So it's going to pick up a couple of rows from here, a couple of rows from here, here, go to this one and go to this one, which is also nice when you have data to mix the data, to do something like this. So right now, we can train our model. This is the super cool moment to start to do some machine learning. So let's go to component and search for a component, which is called train model. There it is. And you need to connect that's it. You need to connect that one to the second one, not to the first one, to the result dataset, to the dataset. Because this is, I don't really like the way that this is defined, but I'm used to do this. So basically, we are going to train the model, but in order to train the model, we need to choose an algorithm. We need to choose, I have somewhere it's here, we need to choose kind of what we are going to use to train this model. So what algorithm? And this is the place that you can start to read a lot in the machine learning world about different algorithms and how they work. This is all about math. Hey, in the machine learning documentation, I just shared a link with you. Can you open the link? There is a super amazing cheat sheet. Sorry if I sound bad with this. I will play my not English speaker card. But here, if you scroll down a little, somewhere here, there it is. So this is a super cool image. I know it's hard to read, but we are going to share the link also for the audience, where you are basically going to, I like it because as a beginner, this saved me a lot of time. So what do you want to do? You want to do some extract information from text? Do we want to do categorization? Do we want to predict values? No, for us, what we want to do right now is we want to predict between 2 categories, which is basically a comment toxic or not toxic. So we go to the first group there, and then we have several options here. We have the chance to see, okay, what do we want to do here? We have a lot of features. Features are basically columns, or we want to focus on fast, or we want to focus on whatever. So this is super useful in order to see what algorithm we are going to use to solve a problem.
What's the best practice for doing something like this? Is it to try a few of these, or would you go and analyze which one makes sense, or how would you tell? Because it seems like there's, for the classification of 2 different classes, it seems like there's 6 options here.
So that's a great question. So in example, remember when we saw the AutoML question, where the AutoML option? Mm-hmm. In the AutoML option, this is going to do this. We are going to give AutoML a set of data, and we are going to ask AutoML solve this problem. And AutoML, what it's going to do is going to do something like this. It's going to go, okay, I need to solve a Boolean problem, a 2-class classification problem. So I'm going to try this model with this configuration, this algorithm with this configuration, this other algorithm with this configuration. And after testing 20, 30, depending on the time that we define run, different configuration is going to give us the best one and say, okay, this is what I find. I learn basically by playing around, because if we go back to the designer.
This one. There we go.
Yes, and you select a component in the component list. The one that we are going to use is 2. And you search for 2.
How do you spell that?
Yes.
Oh,
2 hash. Yes, we have a lot of 2 there, and the one that works better is 2 class average perceptron, the second one there. So you drag and drop this one there somewhere, yes, there, and you connect the output with that one. So, hey, this is a way to do this. We still not run the model. We still have some work to do. But once we finish this, one of the latest steps is going to give us a couple of metrics. One of the metrics is the accuracy. So basically, it's how good is the model working. So we can train with this one. And by the way, this specific algorithm, if you click the algorithm and open the settings, have some configuration. You can go here and say, okay, how you are going to train this model using single parameter or multiple parameter. What is the learning rate? The learning rate is basically when machine learning is kind of a brute force. It's pick up a problem, use configuration 1 to see a value that we have, then configuration 2, configuration 3. So the changes between configuration 1 and configuration 2 and 3 is the learning rate. How big I want machine learning to make these changes. There are plenty of stuff that this is more going to the technical, to the deep parts, but we can also change and test with different configuration here. By default, they are usually works fine. If we want to do something better, we start to need to figure out if we need to clean our data, add more data, remove data, use different algorithm. So there is no easy way to choose the best one. It's mostly test, try, and learn.
Okay, so talking about the learning rate for a second, my intuition says that's based around like the noise of the data set. So if you have something that's really noisy and might produce more chaotic results, having a lower learning rate means you're going to bias less because of those odd results. Is that generally true, or is that just
yes, I mean, the learning rate is just the jump that is going to do. So in example, when it uses a parameter to do an analysis, it's going to jump from 1 to 2, to 2 from 3, for whatever. If we add the learning rate 0.2, it's going to do from 1 to 1.2, to 1.4, 1.8, 6, 8, and so on. Super cool thing, and I was trying to avoid this kind of stuff. If you go in the bottom where you see component information, and you click on Learn More, the other one, this will go into right-click, cancel, right-click, and open a new window. There it is.
There we go.
So you are going to go directly to the official documentation about the algorithm, how this works, how the learning rate affects, how the single parameter or the parameter range affects. So, hey, if we want more info, we can always right-click, not right-click, but click on each one of the components and go to see the official documentation to see how this works, which I do a lot because when you get to a point that you need to do fine-tuning or something, you need to get here and start to read and start to figure out and start to understand how this works. As you see in the bottom, that's the place that I talk and specify how the learning rate works, how it makes sense to have bigger or smaller learning rate. And basically what they said, because the common sense said, hey, if I do my learning rate very, very small, the model training is going to be longer, but it's going to be more accurate because I will cover all of the possible scenarios. No, it's not like this. You are going to get into this scenario which is not going to change anything because the learning rate is so small that it's never going to find a difference to evaluate with the previous one. So, hey, there is a lot of we can talk about, or we can bring people who really know of machine learning to explain these details. But it's a nice try, take a look, learn, try again, and learn from the previous mistakes. So, hey, let's go back to the designer.
Okay.
And what we are going to do now, we are going to score our model. So go for component, score model. There it is. And in score, we have two inputs. One input should came from the trained model, and the other, there it is. And
Cool.
let's add the last one before we will submit. And the last one is going to be evaluate model.
Okay, and that's just going to...
This is going to basically get the score, and we have evaluate model, the second one, I'm sorry.
Oh, right. Yep, not paying attention. There we go.
Hey, no problem. This is going to basically pick up the score model, because score model is going to give us a kind of a big table with data, and evaluate model is going to transform this table into numbers that we can understand. Like an example, our focus is accuracy. So we have almost everything. The only thing that we are missing is that we still didn't tell this experiment what we want to predict. So it's have the data. It's not that it's going to use this algorithm. It's not that we are going to split data 75 and 25, but we didn't tell, okay, and this is the column that I want to predict. So if you go to train model, the train model component, and settings, there it is. In label column, this is what we are looking, edit column, and in the column name, the first one, sentiment, is the one that we have zeros and one. This is the one that we want to predict. So that's it. Let's save the model.
Okay, there we go. Save.
And let's submit the model. And this is interesting. This is going to ask if we want to add a pipeline. A pipeline is kind of, we can define, when we are running these models, we can define kind of pipelines. That's why the name, where we want to basically make groups of the stuff that we are going to use. You don't have any pipeline, let's create a new one. And you can add, it's just kind of a group name here. So go for Wikipedia or whatever. And then when we run the new ones, we can go there. And it's also nice because we can see how they improve over time, where the experiments works. So for us, it's just simple, a name right now. And when we have more, we can start to see this. So let's submit this. There are tags if we want to, again, because this is all in the clouds. If we want to do more, we can use the tags and more stuff. And in a couple of seconds, what we are going to see here in submit jobs, we are going to have a new job. And we can start to see in real time. And this is going to probably takes 5 minutes or something like this. But it's going to, right now, what it's creating is a job into machine learning, the machine learning studio, using the compute that we define to train this model. There it is. If you click on job detail, this should open a new tab. There it is. And in the tab, we are going to see, sorry, all of the tutorials. Yes. And we are going to see step by step what is the, you can collapse this one in the left, the outline.
There we go.
Yes. So right now, the step that is doing is the column data sets. So it's basically, again, it's not doing anything. We have 2 columns and it's selecting 2 columns. And this is working there. And then it's going to do the split data. Then it's going to train the model. And hey, everything is here. And as you see, we switch in the left from the designer to jobs because we are not designing anymore. We are running. We are training a model. And this is not one, and it's so sad that this is not one of the samples, because I think this is the smallest and easiest hello world that you can do in machine learning. Pick up a data set, very simple, with 2 columns, sentiment and text, split the data, choose an algorithm, train the model, and evaluate the model. So this is what we are doing right now. And it's going to take at least 5 minutes. I want to finish one of the steps so we can take a look at this. What do you think? So far, it's kind of easy to see.
So this makes a lot of sense. I think it's because, though, we did this in real time. Like with visual coding stuff, for me, I think it's really hard to open up somebody else's visual coding thing and understand it. So the fact that we did the entire thing, super helpful. I appreciate that. And then we're using a cluster for executing this job that we're running. And so I had that set so that it could scale down to 0. Does that mean that when I'm not running these jobs that my compute resources are 0, so I'm not paying that hourly rate for the services that I'm using? Is that how
Yes,
that
as
works?
far as I understand, and I should probably go back there and take a look. Let me share my screen so we can see the difference, because I have both. While yours is training, let me share my screen. So where is
So if I go over to our compute cluster,
yes, so it's resizing right now. So basically the difference between the compute and the compute instance is that yours starts from 0. So again, as far as I understand, we are only going to pay by the time that we are using this. In the compute instance, the instance is a VM that is turned on or off.
Right.
So in order to do this, we need to turn on the machine. And again, we pay for the time that the compute it's on. The advantage, of course, that we have in the instance is that it's already on, so it's faster to run. The cluster, as we see here, is not even there. It's just provisioning the infrastructure and everything else to start to do the analysis. To train the model.
Okay, so yeah, just to clarify, I have this set so that it automatically scales down to 0 after 120 seconds of being idle. So it should scale down to the minimum nodes because we weren't running any jobs until I clicked that submit thing. And now it looks like it's scaling back up to 2 to run both of them to do this. I chose this because it had that scale down to 0, and so I wasn't going to have potentially like 1 or 2 instances charging me an hourly rate in order to do this. That was why I chose this. But it does seem like there is a little bit of delay in actually starting these because they need to scale up in order to run. So yes, there's some trade-off there.
That's the difference. Let me share my screen super quick to show the difference here. So this is my screen, just in case for the audience, this is my PC. This is my scenario. I have a very similar one. What we see right now is that what Sam showed, that we have here a cluster that is going to scale and then scale down. But the other options is to have these, for me, are virtual machines. It's a compute instance that is running all the time. So this is running, and what I can do here, I can stop this one. So see here, I have this one running, and I can go and stop this. So it's not going to automatically scale that from 0 to 2 to 4 to whatever. It's not going to automatically turn. I don't know if I can. Maybe there is a configuration here that automatically turn off if we have something. I really don't know. I really never play around with this a lot. But yes, this is one of the big differences that we have in both of them. This is nice to have when we are working because it's faster. In yours, probably still provisioning / whatever. But hey, that's kind of also the idea that choose the best tool, no? Choose the best that fits into you. This is, you're only going to pay for the one that you are going to use. And by the way, I think that we both chose the DS11B2, the smallest one, because it doesn't affect our stuff. How is your model? In which step is the model?
It is scoring right now. It just finished training.
Perfect. So I am going to switch back to your PC. Can I switch back to your PC?
Yep.
Perfect. So super cool about this. So in example, let's go up and right click on split data.
Here.
No. Do not open the. Well, okay, let's do this. We can do this also.
Okay. Hey, not this. Okay.
No problem. But what we see here is this is one of the steps. This is one of the components. And take a look here in the logs. We are not going to read the logs, but this is all everything that's happening in the back, everything that machine learning is doing, everything that Azure Machine Learning is doing, we can analyze here. So we have plenty of logs to do. We have, even when we are training the model, we are going to be able to read the Python code using to train the model. But what I was trying to show here, if you can collapse this panel and right click into split data, you have preview data, and you're going to have preview dataset 1 and dataset 2. So if you click in dataset 1, we are going to see, again, we are not going to see how they come, but remember that our original set of file was 250 rows. And hey, for the 75% that we define, we have here in the dataset 1, 187. And of course, the remaining 63 are going to be in dataset 2. So if you right click and preview data in dataset 2, we are going to have the 62. If you click also on sentiment text here in example, we are going to start to see in the right a lot of values here, a lot of statistics around this data. So we don't have, I think, can you expand this a little more?
How's that?
So we have unique values. This is all comments, so there are not duplicated values. We are not missing values, which is kind of nice. So it's nice to do. When we start to work with data and we have problems training the model, we have a lot of values. Missing values, we can start to look here, take a look here, and add a component to remove missing values or these kind of things. And hey, this is text. So we don't have values for the median, the mean, or the max. If you go for sentiment, if you click on the sentiment column, you are going to see here that, yes, this is ones and zeros. So we have some values here. Of course, the mean and the max are going to be 0 and 1. But then we have only 2 unique values. That makes sense, 0 and 1. But this is also kind of analysis, a global analysis of all of the data set. This type of analysis is available for us at any moment. If you close these two, the dataset 1 and dataset 2, and we go to the top, to the first to select columns, you can write here in select columns, preview data, result dataset, and we are going to see here the full dataset, 249 rows with everything else. And if you click on a column, you are going to see the mean, max, median, average, everything there. So at any step, we can even go, and this in this scenario is data easy to read because it's just text. We can even see how the split works, how data we have here and there, how this works, and more. Does this make sense?
I think so. So this gives you a way to just kind of see what's happening. And so since we have a column that's too high, that means there's a duplicate of this entry in our data set. Is that what that's indicating?
No, I don't know why this is the frequency. That's basically how often we have that, but no, I need to go and start to take a look at the data to see why we have this one value with 2. Really don't know. I can't remember why we have that. Hey, we have a good question here.
Yep.
I am going to bring the question to the screen. Pablo asked that he saw Python code using Azure ML library. If we can use this package in your local machine. Yes, that's one of the idea. If you, in example, have a team and the team is publishing dataset to Azure Machine Learning, and you want to use Azure Machine Learning, those datasets in your machine, you can use the libraries to access those. Of course, if you have the credentials, if you can access there is a security layer here that we can talk about. But yes, you can do that, and that's a super cool scenario also for small tests in your machine and then run big on the cloud. Hey, my guess that we should be done. So if we go back to the bottom, it's still scoring. Oh my God, so slow.
We can talk about the running locally though, because I think if I jump here to the home, there's an extension for Azure Machine Learning in VS Code, for example. And there's links from Azure Machine Learning to open things in VS Code or open terminals and things like that. So that might be an option. I ended up here. I don't remember how, but that seemed relevant. So yeah. Yes,
and now that you are there, if you want, I opened code without wanting. If you open, and again, this wasn't part of what we plan to do, but maybe it's nice to show. If you install this extension, once you install this extension in your Azure panel, you are going to, there it is, you are going to see somewhere there machine learning, there it is, and you are going to see your resources from Azure Machine Learning here. So from here, you can, I can't remember what you can and can't do because I haven't used this in a while, but my guess is that yes, you have basically everything that you see online. You have the dataset, experiments. If we go for datasets, we are going to see your dataset, the wiki, and we can probably right click and take a look at the version, that's it, view properties, and hey, Everything is available here. And my guess is that in the experiments that we see here, we are going to see the one that we just create, Wikipedia, and we see the steps. So this is another way to do this. This is basically when the experiment start to see code, and we can start to see, okay, this is what is running in this order, and right now is doing this and that. And you can check the logs, you can do a lot of stuff, and you can even download the logs and analyze this. There are plenty of stuff that you can do here, but again, I haven't used this in a while, in a very, very long time.
Okay, and I haven't used this, so okay. But yeah, I guess it's there if people want to play around with it.
Yes, and again, now that we know that Pablo is online asking questions, hey, Pablo, question for you. What do you think about the format? This format of two people interacting, learning. We really, really want to know if this makes sense to do more. So if Pablo or someone else can give us some feedback, that will be great.
To add
this
to
is
that,
still working?
Yeah, yes, it looks like it. Sorry, to add to your question about if the format's good, if you like the format, what would you want to see in like August? For example?
Yes, that's a good question. What are the next topics?
There certain things that you would love for us to explore, maybe with Bruno and me, or with other people. What would be interesting to kind of bring this format to? So let us know.
Let us know, please. Yes, let's do this because let's wait until it's finished. Let me share my screen. I want to show you how this should look once it's finished. So I have here my designer. Hey, I like it. Work for me. Thanks, Pablo. This is what we want. So I have here Wikitalks 250. So basically, this is your very similar to yours. I am not very good organizing my components. This is kind of a mess, all bad connected. But once I start to run my jobs here, I can start to see how many jobs are submitted, and I can start to see how they work. Here in my job list, I will see in Wiki, I will see several of them working and not working. And even I have a couple of them that fail. This is what we start to see when we start to run our models. Remember that we start to, give this a name. So this is my name, and I see this one fail. And why this one failed? So I will see, let me minimize here a little. I will see step by step here that there was something wrong here in train model. So let's see what's happened here. I can go to the job overview, and I will see, click here. And I will see, there is a lot of comments values here greater than unallowed. So I cannot use this one because I have a lot of duplicated values in order to do this. So I was playing around trying to break this one to have some errors, but when we train a model and it doesn't work, this is what we are going to see. We are going to see which step. You can see here green, and a red. Which step is the one that have problem, and we are also going to see some kind of error. As we've seen before, I can even get here and start to check the logs. I can even start to check the logs of what is happening here, and this is going to be huge machine learning execution log, super ugly to read, but if you have time, this is a great place to learn. But what I want to do is, once it runs successfully, this is what we are aiming. This is one that we can see we have all of the steps and everything runs successfully. There are a couple of things that we can do here. First of all, we can go to evaluate, right click, and preview data, the evaluation results. So here on the right, we are going to have several metrics around how this model is scoring. And what we are looking for in this one is these two. The accuracy and precision basically is how good is our model. 0.6 is not, this is 60%, so it's not very good. But hey, for us, working with this very small data set, only 250 text rows, it's kind of good to know. So this is the place that we can start to take a look at the metrics of our model. And this is also the interesting part. I can create an inference pipeline. This is going to pick up my trained model and is going to create a new designer model. And let me switch to this and show you. Let me know when you finish so you have this one already done. But this is going to...
Sorry, we're done on my side too. So
you're gone? Okay, so I am going to show this and then go back to you to see if we can finish. But this is what we create in inference, real-time inference, which is basically a new type of model, a new type of designer that is going to pick up the model that we register and is going to add an input of a web service model. Then is going to use the model that we have here, the trained model that we have, and is going to do a score and is going to give us an output. At the end, when we run and we publish this, what we are going to have here is an endpoint. Because remember that I told that in Azure Machine Learning, we can manage everything. An endpoint that is going to be a public REST endpoint. By the way, I'm going to delete this later. We have the Swagger UI if we want here, if we want to open this and get information. And we can even have here some sample code in C#, Python, or R to consume this. This is a standard HTTP request, which is an HTTP client that is going to basically send an input with a set of sample data, and is going to show us JSON with the results here. So we have this. I can do something, a test here, and change it. Not going to do, I don't have time. But hey, this is kind of the idea. Let me test this. Only one sentiment. So sentiment test is going to do this is great. I am testing this. The sentiment is 1, so I think it's good. And let's do this. Sucks. I think this is going to be bad. Still going to give me. Oh, sorry. I need to. Scored label is the one that is going to change. So this is great. Scored label is 1.
Yep.
This sucks. Scored label is still 1. I don't want to be rude typing. This is the part I don't like with this sample that need to write something very bad and try to be a nice person. But this is the real model already published as an endpoint using machine learning here. How do you publish this? So you have your A key. We can talk about how you publish your endpoints here, but basically use Azure Kubernetes services to host and use this online. So if you want to do the last step in yours, let's switch to your machine one last time. We have still 2 more minutes. And hey, if we have more questions online, happy to answer those questions. But you see here complete. Perfect. So you have the chance to press S5 in the browser. I don't see the deploy.
Okay. We are in the job. Would that change anything, or are you looking for?
No, there it is. Now, did you see that you have create inference pipeline in the toolbar? The last option. Yes. The main option there is that you can create a real-time inference pipeline, which is going to be kind of a submit a sentiment one by one, or a batch where you can batch a lot of data and it's going to give you back a lot of data. And hey, you have this. You can submit this one directly here. You have the submit button and it's going to train this, choose your Wikipedia and submit. And this is going to train basically a pipeline to publish this as a web service. It's going to take some time. Again, like the previous one probably is going to scaling down. But this is kind of the idea, to manage your models, to manage your pipelines and everything else without even need to write any lines of code.
Right. So we probably should mention we're using a really small data set for this. We had 250 things. That's probably why your sample was not coming back with why our accuracy was 60% and why some of our things were coming back, our tests were coming back with things that we didn't quite expect. Thinking like this is great is not a nice thing to say, or some toxic comment when it's pretty okay. So I think part of that is just the size of the data we have.
The size of the data, yes. Yeah. And hey, we are not testing this right now here, but this is the moment that we can probably go back to our original design, change one of the algorithms that we were using, the 2-vector class. I think, hey, let's pick up another one. Let's pick up the 2-vector SVM or SVG and try with that one. Maybe we have better accuracy there, maybe not. So that's also a moment that we can start to play around to see how other models work here on how they have this. Again, yes, as you mentioned, this is a super crappy example, mostly to know the environment, to know how Azure Machine Learning works, but it's a super cool one. And another note, in the job that we see before, can you go to jobs in the right there? Can you open Wikipedia and open the completed one? You saw the button publish. That publish is not going to publish this as a web service. That publish is going to publish. Click on publish if you want. It's going to publish the trained model. Well, again, you need to choose a pipeline. It's going to do everything work with pipeline here. We need to create a new one. Sorry, this is not yes.
Different thing. Okay.
This is going to publish the trained models to be available in the model registry. In Azure Machine Learning, we also have a repository where we can publish our models, we can version our models, and people can access those models. So as Pablo was asking, using the Azure Machine Learning SDK, you can connect to an Azure Machine Learning environment, workspace, access to one model, download and use the model. And if someone updates that model, when you do this again, you're going to get the latest version. So this, in example, when you do this and it finishes, it's going to take some time, you are going to have your model available in the model section here.
Okay. We do have one quick question asking if you can use something like TensorFlow to integrate with Azure Machine Learning.
Yes.
And then we should probably wrap up after that.
Yes, we are over the time. So sorry about that. Yes, Pablo, we can use TensorFlow. I never use TensorFlow here in the designer. I use mostly TensorFlow in the notebooks, which is basically coding, pure coding. Most of the code here is use also PyTorch, all of the core, because Microsoft is a huge sponsor of the PyTorch library and the PyTorch community. But yes, there are a lot of notebooks here in the samples that use TensorFlow. So that's another way to do this.
Awesome. Cool. Thank you everybody for watching. There are some survey links in the chat or on screen. If you fill those out and let us know. We're trying to figure out if this is something we should continue doing into August and September and so on. So if that's something you want to see more of, if you like this format and want to see us learn more together, let us know through that, or just reach out to us and let us know that way. And yeah, thanks everyone. Anything you want to say?
Bruno, do you want to say anything? No, if not, thank you everyone for joining. I have added the link to tomorrow's session. Bruno and Sam will be back. We hope you can all join us then. Thank you. Have a great one.
Thanks everyone.
Bye.